everyone. Today I have come up with a new video, and this is on the hot favorite topic, and in fact, one of the most disturbing topics for the PM students. They find a lot of difficulty in tackling Section C questions. And we know that typically Section C questions are tested from the different decision making techniques, budgeting questions, the budgeting topics, performance measurement, analyzing the performance and the non-performance measures, and variance analysis, then the building block models, balance scorecard, quantitative analysis, ratios, and so on, transfer pricing. So these are typically the topics which are frequently tested for Section C questions, and this is the complete testing area. So now comes the point that, ma'am, how should we handle these Section C questions which are coming from these topics? So I have picked up 5 topics and one question for each of these topics. And I believe if you do these questions from these topics that we have taken here, I'm sure these topics will be like a smooth transition for you in the exam, and you would be able to handle any question that is coming from these topics. So let's analyze and let's understand how to solve Section C questions for each of these 5 topics. First topic that I've taken up is constraints. Again, a very frequently tested topic, not just for Section C but Section B as well. Okay, so here what I'm going to do is I'm going to read the question and we will try to complete or solve 50% of our answer while we are reading the question only, so that when you are actually going to the requirements and solving the question, it becomes much easy for you to handle these questions. Okay, so let's look at the first question, that is on Bell Houston Company manufactures 3 types of running shoes which it sells to sporting clothing retailers, sports clothing retailers. Roads is the first shoes which is for running on roads. Spikes is used for racing on athletes, tracks, and a trail which is used for running off-road in rural locations. Each of these products, they use different amounts of the same resources. Financial information and the resources requirements relating to these products is listed, which I'll come to it later when we are solving the question. Fixed overheads are absorbed at the rate of 4 per direct labor hour. Bell Houston Company is using a JIT system. Demand and resource availability for the month of March is given to you here, where the demand for the 3 products is expected to be this 2300, 1400 and 1650 respectively. Bella Houston Company has received a special order from Run Wild, which is not included in demand estimates above. So that means these are additional supply to be done. Run Wild, they are a major sports retailer. That means they have a very good customer base and who have an extensive customer base and are known for stocking the most popular brands of the sportswear. So if Bella Houston gets a recognition there, I mean, it's a big recognition for them, right? This is the point to be focused. Generally in Section C kind of questions, if you have to write theory, these pointers add on. The order is to supply a maximum of 200 pairs of each type of shoes at a discount of 8 on standard selling price. That means when we're calculating the selling price for these products, we will reduce 8 from the normal selling price. And if we have to see what is the total production to be done, I mean, considering that everything is available and there is no constraint, then for road, we will not make 2300 pairs, we will add 200 with it. And actually, we will focus on making 2500 pairs. Likewise, here also we will focus on making 1600 pairs, and here also 200 will be added to focus on making 1850 pairs. Okay, now Run Wild will charge a financial penalty if the order is not fully complete in March. If this first order is successful, then Run Wild will be keen to enter into the regular supply contract. That means it is going to get a long-term contract for the customer. That is Bella Houston. Usually, Bella Houston companies sufficient resources to meet the production. However, during March, the maximum availability for the following resources has been identified. And what is it identified? Let's see. Now, let's go forward. So, usually Bella Houston companies sufficient resources to meet production. However, during March, the maximum availability for the following resources have been identified. Stop here. When it says that it is maximum availability, it should give you an understanding that there is a constraint here. There is no use of the term bottleneck. That means we will focus on contribution per whatever is a constraint. Is it direct material, labor, or machine time? That we will find out. So why don't we find out now? Now let's see. The total requirement to manufacture is 2500. In this data, it's given to me selling price per pair of shoes. Variable cost details are given to me. This is in dollars. Direct material $5 per meter, dollars. Direct labor $7 per meter, and machine hours is $10 per hour. Fixed overhead absorbed is a per pair of shoe. But we have to focus on direct material, labor, and machine hours. As there, we have to understand which is the constraint. So I need to know the quantities and the kgs. Now, if direct material is $5 per hour, I think it is 7.5 is the total cost. So what is the material in meters? Let's calculate. 7.5 divided by 5, it gives me 1.5. And here it will give me 3 divided by 5.6. And here it is 6 divided by 5, 1.2. So this is in meters. Okay, in your exam also, if you want, you can just write it down in the rough side so that you do the calculations. When you do some calculations with the question, it makes you very, very comfortable. In fact, you can do it on Excel only directly. Okay, and then we can see the requirements. Of course, here ranking would be a requirement in these type of questions. So why don't we just parallelly while we're reading, do these questions, parts. Secondly, for the direct labor, 7 upon 7 hours would be 1 here. 10.5 upon 7 is 1.5 and 7 upon 7 is 1. For machine hours, you just have to divide again hours, 0.4, 2 divided by 10 is 0.5 and 3 divided by 10 is 0.3. Oh, I'm sorry, 2 divided by 10 is 0.2, not 0.5. Okay, now fixed overhead absorbed per shoe is given, but now we know these quantities. So can we say that to manufacture 2500, 1600 and 1650, what will be the total quantity needed for direct material, what will be for direct labor, and what will be for machine hours? Yes, I can find out. So what I'll do, I'll list here direct material, direct labor, and machine hours, and see which is the constraint here. So 2500 multiplied by 1.5, 3750, then 0.6 multiplied by 1600. We are multiplying the U quantity with the labor, with the this, what do you call, with the meters that is required for each of the product. Okay, to see whether the requirements are being met or not. The next one is 1.2. So 1.2 multiplied by 1850 is 2220. Get the totals and we'll get the totals together, and let's do for labor as well. Labor is 1, 1.5 and 1. So 1, it means it will be 2500, and here also it is 120, no, it is 1850. And the next one is 1600. 1600 into 1.5. That will give me 2400. We'll get the total here as well. For machine hours is 0.4 multiplied by 2500. That is 1000. Then 0.2 multiplied by 1600. It is 320, right? And then the next one is 1850 multiplied by 0.3. And we get here 555. Let's get the totals now, guys. So let's do the total here. First one, direct material, 3750 plus 960 plus 2220. I get 6930. Labor 2500 plus 2400 plus 1850. I get 6750. Machine hours 1000 plus 320 plus 555. I get here 1875. Okay, I get these figures. Now let's check which is the constraint. So material available is 7200 meters, 6930 is the requirement. It is not the constraint, right? Then Labor hours is 6900 available, 6750 is the requirement. Again, it is not the constraint. Not 1815 is the machine hours available, but we require 1875. So there is a shortfall here for the machine hours, hence machine hours is the constraint. That means now what you need to do is you will calculate contribution per machine hour. Can we calculate it? Let's do it here. So road, spikes and trail. Contribution per unit. We know the machine hours that I've written it here already. So I can get contribution per machine hour. Okay, and then we do the rankings. So let's do what is contribution per unit. Simply guys, don't run brains. Profit plus overheads will give you contribution. So just add it. 37.5 plus 4 is 41.5. Here it is 29.5 and here it is 36. Okay, contribution per machine hour will be 41.5 divided by 0.4. I get here 103.75. Right, I'll just calculate it again. 41.5 divided by 103.75. For S, we will get 29.5 divided by 0.2. I get 147.5. And for the third one, I will have 36 divided by 0.3. And I get here 120. So now we can do the ranking. As per the ranking, the maximum contribution is this. So let's make spikes first, then target on making trail, and then target on making road for the remaining hours. Because we have restricted hours, we don't have fully available hours. Clear? So now we are done with ranking part as well, right? So now we have clarity that if we have to maximize contribution, first focus should be on the manufacturing of spike, then trail, and then the roads. Okay, now let's move further in the question. Demand and resource availability for the month of April. Now this was for March and now we are talking about April here. Bella Houston Company predicted that resource availability in March would continue into April. However, it has been discovered that the availability of direct material and direct labor will be 15% less than in March. So now this quantities you will reduce by 15%. That means availability in the month of April will be, so April availability will be 6120. What I did, 7200 less 15%, and 6900 less 15% will be 5865. So this will be the available hours and this will be available meters, right? And it says that available machine time and demand will remain unchanged. So demand is same, machine time is same, 1815 hours. Okay. That means you will have restrictions here, right? Because we require, yeah, we will see in the question now. Now let's see the question. Calculate the optimum production plan. The first part always you will focus on. Okay, always focus on the first part only. Calculate the optimum production plan and the resulting total contribution earned for the month of March, assuming that the order will be supplied in full. That means we will first supply run wild in full. It's like a specific customer order, and then we will see the regular customer orders. Now, guys, we have done the ranking, right? Now, quickly, let's look at that. How should we plan? Now, what should be the plan now? To make 200 units of road, spike, and trail first, as that this order is to be satisfied in full. After that, the remaining units we will first make for spike, as it gives us the maximum contribution to meet the maximum demand, then meet the demand for trail, and only for the remaining hours we will manufacture roads. Let's have a quick look at it. And as this was to guide you, let's have a quick look at how would you be solving it. So the first one, when we see here, it is like we discussed. First, we will make full customer order for 200 roads, spikes and trail. And then in the sequence of the maximum contribution, we will make spikes first, trail first, and 2150 units of only roads, because for the hours that are available, only for those hours we will manufacture roads. So we get a contribution of 211,122,5. Okay. Likewise, let's go to the second question. It says, calculate the maximum financial penalty. What is the maximum penalty that Billa Houston would be prepared to accept from Runwile if it does not complete Runwile's order in full? First, understand the question. What is the requirement of the question? That what is the maximum penalty that Bella Houston would be ready to accept? So, what will be the maximum penalty as per you? The contribution that it will be losing, because first we did what we did, that we satisfied the order in full, and then we allocated the hours to the remaining products and to the products in the ranking of their contribution to earn maximum contribution. Now, if we do not fulfill the Runwile's order, then in that case we may have lower contributions, no, or higher. I mean, whatever is the thing that's just calculated, generally it will be lower only because you're not meeting fulfilling that order. So if you're not fulfilling that order and the contributions have gone lower, then what is the penalty that Billa Houston will be ready to give? The loss that it is going to suffer because of the loss in contribution. So that is the maximum acceptance level for Billa Houston, right? We're just finding that. Now you will redo the same calculations, but now you will not start with 200 pairs of the three products, because now the aim is not to make them in full. The aim is that to have the maximum production that we can. So what we will do, we will do the maximum production of it's meeting its regular demands of 7,200 of 2,000 pairs of road of spikes and for trail. So first we will allocate the hours towards them, then we will allocate it towards the remaining hours. So then we will give remaining hours of 200 to the 200 pairs that we have to make specifically for Runwile. Right now here you will do it in the sequence of your contributions. So of course, also one more point, that here there is a discount of 8. That means you will not have a selling price of 62. It will be 62 minus 8, 56. For spikes, it will be 45 minus 8, 37. And for trail, it will be 52 minus 8, again 46. So you will use that selling price, you will get the contribution. And now that you will allocate on the hours, you will allocate to the different products for the manufacture of this Runwile products in the same ranking of contribution. That means first we'll make for spike, then trail, and then road. Similarly, so look here how we are going to do. So you can do your first we'll make for spike, then trail, then road for the remaining hours. Got it? And we made the existing production in full because the requirement was that now there is no need that the Runwile products will be made in full. So they are placed at the end. Now here what do you see, the contribution, it is increased, not decreased. It is increased to 212,425, and here it was 211,125. So this is the increase that is taking place. So what does this increase reflect? This increase reflect means this 1200 which is increase. So Runwile will go for maximum contribution. Then they will not like to manufacture the Bella Houston would like to go for maximum contribution. So they would not like to manufacture for Runwile first then, because that is not giving the maximum contribution. Hence they will say, okay boss, Runwile, we are not able to complete your products, but you maximum penalty that we are ready to give is 1200 only. Okay, so only 1200 will be offered as the penalty. That is the maximum that Bella Houston would like to offer. Okay, next question. Discuss whether Bella Houston's company should fulfill Runwile's order in full in March or not. Now let's look at the different pointers, financial and non-financial as well. Financial pointers, and just see the question is for 4 marks. 4 marks means at least 4 to 5 valid points we require in this question. First valid point can be the financial difference that we just discussed, that if they go for this order, then they're losing a contribution of 1200. Second point can be this, I would like to take the point from here. If they don't make the product in full, then Runwile will not go ahead with the future contracts. And if they make the product in full, that is the Runwile order in full, then they can allocate a regular supply contract also, which is a very, very big thing and very good promotional strategy for Bella Houston products, as Runwile has a huge customer base and it keeps a lot of popular sportswear brands. So it is direct relationship with a direct kind of an advertising and marketing for Bella Houston that its products will have. And also on the other side, see if the other sports retailers, they come to know that Bella Houston was not able to meet these product requirements, then they might also feel that, let's not place order with this company because they don't meet their targets. So this is where the overall reputation of the entity can go down. You can write about this as well. Just pick any 4 to 5 relevant points and you're done, and you will secure full marks here. Okay, let's go to the next one. So the next question is, define the variables and formulate the constraints and the objective function to be used in linear programming model to determine the optimum usage of resources. So 5 marks. We just have to draw down the constraints and the contribution equation, because objective function is mentioned here. That's all, and you will get your marks. So ideally, I think there will be at least 5 equations. Otherwise, they will not give 5 marks here. Okay, let's look here. So now here, when you see for the month of April, they want, right? Now in the month of April, the material available is only 6120, but the requirement is 6930. Labor is also less, machinery is also less. That means all these three are going to be constraint statements. So how we are going to create the statements? You know the quantities. So let's it be R, road be R, spikes be S, and trail be T. With this, if we formulate the equation, my first equation will be 1.5 R plus 0.6 S plus 1.2 T is less than equal to 6120, right? Because then only we will be able to meet it. This is the maximum quantity available. So first statement can be 1.5 R plus 0.6 R, plus 0.6 S plus, I think it's better if I formulate the equations there only. Much helpful. There is no space. So let's formulate it here. Okay, 1.5 R plus 0.6 S plus 1.2 T is less than equal to 6120, because they cannot exceed it. Likewise here for labor, 1.5 and 1. So that means 1 R plus 1.5 S plus 1 T is less than equal to 5861. For machine hours, 0.4 R plus 0.2 S plus 0.3 T is less than equal to 1815. Got it? Now we have other equations also. Demand is also limited. So let's create the demand equations also. R is less than equal to 2300. S is less than equal to 1400 because they have a restricted demand. And T is less than equal to 1650. Let's have the non-negative general equation that we create, that R, S, T are more than equal to 0. Now let's make the objective function. So objective function would be made with the use of a contribution. So contribution is here, we had calculated 41.5, 29.5 and 36. So 41.5 R plus 29.5 S plus 36T. This is the maximum contribution that we will have.